for part 2 review over trig identities and solving equations. My stylus is not working, so I'm going to be using just my fingertip to write and draw, so I apologize in advance. It's not going to look as nice as it usually does. All right. All right, in the first section, we are finding all solutions of each equation. These, no identities are required. This is just your algebra skills and then knowing your unit circle. And remember, you're going to get the unit circle with quadrant 1 filled in. So the goal is to isolate that trig expression, so sine of x. So to get sine of x by itself, we need to get rid of that 2. So we're going to divide by 2. And it cancels that, reduces the 2 over there. So we get sine of x by itself. Even writing all the strokes I'm doing, sorry. So we have sine of x equals root 2 over 2. So now once you've isolated the trig expression, we got it by itself. Now it's a unit circle question. Where is sine root 2 over 2? Well, sine is positive in quadrants 1 and 2. And then it's at the 45 or the pi-4ths reference angle that it's root 2 over 2. So it's that 45 or pi-4ths reference angle in both quadrant 1 and 2. So in quadrant 1, that's pi-4ths. And in quadrant 2, it is 3 pi-4ths. Okay. Number 2, we've got cosecant of x on both sides of the equation. So we need to get it's the same trig function, but to be able to combine it, we need to get them to the same side. So I'm going to take the 2 cosecant x from the right and move it over by subtracting. What you do to one side, you do to the other. Okay, so over here that reduces or cancels to a 0. And over here, I've got 3 cosecant x's minus 2 cosecant x's, so I'm left with 1 cosecant x. And on the right side, I'm just left with that positive root 2. So I've isolated that trig function. That's what I needed to do, get it by itself. Now it's a unit circle question. Now I don't have cosecant memorized on the unit circle, so I highly doubt you do, but we know the reciprocal is sine. So sine, oh my gosh, it's not taking the n, there it goes. Sine would be the reciprocal of this, which the reciprocal of root 2 is root 2 over 2. Because remember, if you take the reciprocal, I take root 2 and I flip it, it becomes 1 over root 2. But if I rationalize by multiplying by the radical in both the numerator and denominator, I end up with root 2 in the numerator and just 2 in the denominator. Okay, let me get rid of that for now, so we have some more space for the next problem. All right, so now it's my unit circle question. Where is sine root 2 over 2? That's the same as number 1. So it's going to be the same answer. The positive root 2 over 2, just like number 1 was. So it's going to be the pi-4ths and the 3 pi-4ths. Oh my gosh. Not taking my writing. Make it bigger. 3 pi-4ths. Really doesn't want to accept my writing. All right. Now on number 3, There's sign on both sides, but it's different than number 2 because one of them is squared and one of them is not. So I can't just move them to the same side and combine them. I am going to move them to the same side, but I'm not going to be able to add them together or subtract them because that's like having x squared and x. You can't add or subtract them. So I'm going to move this sign of x over to this side by subtracting it. Okay, so I'm subtracting sine of x from both sides, and I end up with 2 sine squared x minus sine x equals 0, because there's nothing left on the right side once I move that over. Now I can't combine them, but I can factor, because both of those terms, I say both, here's a term minus another term, and those two terms have a greatest common factor of sine of x that I can factor out. So I factor out sine of x, and in the first term I'm left with the 2, and then the sine of x minus, and then in the second term I'd be left with just a 1, because if I divide sine of x by sine of x, it's just an understood 1. I have to write it though because it's being subtracted, it's not being multiplied. So then you split and solve. So I set each factor equal to 0. So over here I have sine of x equals 0. And then over here I have this expression equals 0. So I need to isolate the sine of x. So I'm going to add the 1 to the other side. Okay, and then I'm going to divide out the 2. So once I divide that by 2, I end up with sine of x equals 1/2. If the pen will let me write. Computer, it doesn't like my fingers for some reason. Okay. So I've isolated the trig function in both factors. I'm ready to use my unit circle knowledge to answer. Where is sine 0? Remember, sine's the y value around the unit circle. So that happens at 0 and at 180 or pi if we're answering in radians. Where is sine 1/2? That happens in quadrant 1 and in quadrant 2 again because it's positive 1/2. So the y is 1/2 at the 30-degree or pi/6 reference angle. So that's going to be, come on, here we go. So pi/6, then quadrant 1, and I don't even have room to write all of this. Pi/6, and then in quadrant 2, that would be 5 pi/6. Yeah. So you had 4 answers there. Okay, let's go down to number 4. Now this one is a trinomial. You've got 3 terms. Got the cosine squared, the 4 cosine, and you've got the 3. Okay, and it's already set equal to 0. So this isn't GCF factoring, but it's the quadratic trinomial form factoring. This is where it's going to factor to 2 binomials being multiplied. Okay, when your A value here is an understood 1, you're just looking for what multiplies, what multiplies to C, different color here, multiplies to C, which is 3, but adds to 4, the B. So it multiplies to C, but adds to B. And we can do that because this is an understood 1 A value in front. So it multiplies to 3 is 3 and 1. Hey, that also adds to 4. So we know that this is going to be 3 and 1, and they're both going to be positive because they need to multiply to a positive and add to a positive 4. And then the lead terms are the factors of cosine squared, which would just be cosine x, cosine x. So I've got my two factors. I'm going to split and solve. I'm going to set this factor equal to 0. And so I would have to subtract the 1 over. So I would end up with cosine x equals -1. And then for this factor, I would have to subtract the 3 over. So I'd end up with cosine x equals -3. So now it's back to unit circle knowledge. Where does cosine equal -1? Cosine is the x value. The x value is -1 at 180 or pi. Okay, where's cosine -3? Nowhere. Remember, the cosine range is -1 to 1. The unit circle, that radius is 1. So the furthest it's going to get is 1 to -1. So that one has no solution from this side. So you can write that, or you can just box in the one from the other factor. This is your only solution there. Then in number 9, we've just got a single trig function again. So this one's going to be a little simpler. We need to isolate it. So I'm going to get rid of that 9 by subtracting it to the other side. So then I've got cotangent squared of x equals, and then 12 minus 9 is 3. Now to get rid of the square, I've got to take the square root. Now here's where you have to make sure you don't mess up. We have to put plus or minus in front of our square root when we do that as an operation to get rid of something for solving. So we end up with cotangent of x equals positive or negative root 3. Here's another one. I don't have cotangent memorized, but I do have its reciprocal memorized, which is tangent. So I can change this to tangent and take the reciprocal over here. I still have plus or minus, but the reciprocal of root 3 would be root 3 over 3. It's the same concept I showed in number 2. When I did the reciprocal of root 2 was root 2 over 2. So now I'm asking myself, where's tangent root 3 over 3, positive or negative? So that's going to be all 4 quadrants because it doesn't matter if it's positive or negative. So I'm going to have 4 solutions here. Tangent is the root 3 over 3 at the 30 or the pi 6th reference angle. So it's your pi 6th angle from every quadrant. So 1 pi 6th, 5 pi 6th, 7 pi 6th, and 11 pi 6ths. Okay, now on to the last one in this section, number 6. And my screen is not receptive. So I've been shifting over. I don't know what's going on. Oop, now it did something. Hang on, undo that. Okay. All right. Same concept. We've got a single trig term we want to isolate. So we're going to get rid of that 4, but this time that's dividing. So that 4 is being multiplied. So the opposites divide. So I've got cosine squared x equal to 3/4. But I'm going to have to do the same step of taking the square root to get rid of the square. I have to remember that plus or minus. Now this time I'm taking the square root of a fraction. So I also need to remember that when I take the square root of a fraction, you're taking the square root of both the numerator and the denominator. So the numerator is 3. That's not a perfect square, so we leave it as root 3. 4 is a perfect square. The square root of 4 is 2. So we end up with square root of 3 over 2. Again, plus or minus, so we're going to have 4 solutions because all 4 quadrants. Cosine's the x value. The x value is √3/2 at your pi6th reference angles. So this is another one. We've got a repeat answer. It's actually all the same answers from number 5. It's pi6ths for quadrant 1, 5 pi6ths, 7 pi6ths. Man, that's not pretty much easier. And 11 pi6ths. All right. So that is it for that first section. Trying to zoom out for you so we can look at it all, but I don't know what's going on with my here. There we go. All right, so that's that first section. Solving. To isolate the trig function, algebra skills to do that. Things like opposite operations, factoring, taking square roots. Your factoring could be GCF factoring, it could be quadratic form factoring. Got to know all of that. And then your unit circle, knowing your unit circle. Once you isolate the trig function, then you've got to know your unit circle values. All right, I'm going to stop this video here and I'll do a separate video for the next topic.